Dear friends, today I will discuss with you some important MCQ from the chapter solution. First question, the Vanto factor I for a dilute aqueous solution of the strong yellow chloride barium hydroxide is what? You see barium hydroxide, it is question number 1. Barium hydroxide you are taking and it dissociates as Ba plus 2 plus 2OH minus. Okay, so the number of ion you are getting here, barium ion 1 and OH hydroxide ion 2. So number of ion total is 3. So the Vanto factor, that is D, correct answer. Okay. Next, the freezing point depression constant for water is minus 1.86. If 5 gram of sodium sulfate is dissolved in 45 gram of water, the freezing point is changed by minus 3.82 degrees centigrade. Calculate the Vanto factor for sodium sulfate. So whenever such type of question is asked, you have to use the formula where Vanto factor is used. Okay. So question number 2. So your formula delta TF is equal to IKF and molality. Okay, so for I you have to find out delta TF is given 3.82. Okay, KF is minus 1.86 minus 1.86. Okay, then molality, for molality you have to put the formula W2 by M2 by 1 by W1 into 1000. Okay, so what is W2? You are taking 5 gram. 5 gram of sodium sulfate is added. So I multiplied 1.86 and 5 gram molecular weight of sodium sulfate, that is 142. Okay, 1 by W1. The solvent 40 gram of water. So it is 45 gram and 1000. Okay, this much is equal to 3.82. So by solving you will get I is equal to 2.62. Okay, so which one is the correct answer? 2.62 is the correct answer. C is the correct answer. Next, question number 3. A 0.1 molar aqueous solution of weak acid is 30% ionized. If K for water is 1.86, the freezing point of the solution will be what? Okay, see question number 3. So what to do? Weak acid HA dissociate as H plus and A minus, and it is 30% ionized. So initially it is what? 1 mole is taken. After some time 1 minus alpha changes to alpha and alpha. So here 1 minus what is alpha? 30% dissociate, that is 0.3, and this is 0.3 and this is also 0.3. Okay, so total I value is equal to 1 minus 0.3 plus 0.3 plus 0.3. So you will get what? You will get 1.1 plus 0.3, that is 1.3 you are getting. Okay, so then formula delta TF is equal to IKF. Okay, and molality. So delta TF I value you are getting 1.3, KF value is given 1.86 and molality is given 1. So by solving you will get 0.2418, that is which is approximately equal to 24. Okay, so delta TF, so TF is equal to 0 minus 0.24, that is minus 0.24. So the answer D is the correct answer. Okay, next, benzoic acid undergoes dimerization in benzene solution. the Van factor I is related to the degree of association X of the acid is as what? So these are the choices given. You see question number 4. What to do? Benzoic acid C6H5COOH. Okay. So it will dimerize. So you take 2 molecules C6H5COOH twice, that is dimerization. So initially you taking 1 mole, it is association is 0. So after that 1 minus X, see this X is converted to X by 2 as association. Okay. So total I is equal to 1 minus X plus X by 2. So you will get what? 1 minus X by 2. Okay. So I is equal to 1 minus X by 2. I is equal to 1 minus X by 2. Choice C is the correct answer. Okay students. Next, the freezing point of benzene. Question number 5. The freezing point of benzene decreased by 0.45 degree when 0.2 gram of acetic acid is added to 20 gram of benzene. If acetic acid associated to form a dimer in benzene, percentage of association of acetic acid in benzene will be what? Kf is given. Okay, 5.12 for benzene. Okay, so how to do? You see delta TF, question number 5. Delta TF observed value is equal to 0.45 degree centigrade. Okay, the calculated delta TF calculated value is equal to 1000 kf W2 by M2 and W1. So you put the values 1000, kf value is given 5.12, this one kf value is given, and W2 how much given? 0.2 gram, and M2 60 acetic acid molecular formula, and 20 gram of what? Benzene is taken, 20 gram of benzene is taken. So by solving you will get how much? You will get 0.853, okay, degree centigrade. Okay, so I is equal to Van factor I is equal to calculate observed value is 0.45, calculated is 0.853. So you will get 0.527. Okay, then what to do? Now acetic acid dimerize CH3COH 2 molecules dimerize CH3COH twice. So initially after some time it will dimerize, 1 minus alpha changes to alpha by 2. Where there is dimerization you took alpha by 2. When there is a dissociation you take simply alpha. Okay, understand? Yes. So total molecules I is equal to 1 minus alpha plus alpha by 2, that is 1 minus alpha by 2. So what is I? I is equal to 0.527 is equal to 1 minus alpha by 2. Then what is alpha by 2? You bring alpha by 2 one side and 1 minus 0.527 and you will get 3, and this is 7, and this is your 4. So 0.473. Then what is alpha? Alpha is equal to multiplication of 2, 6, 4, and you will get 9. So 0.946. Then percentage association, that is 94.6%. Okay, so which one is correct answer? 94.6 is the correct answer. Okay students, next, a 0.00 molar solution of sodium sulfate is isotonic with 0.00 0.01 molar solution of glucose at the temperature, the apparent degree of dissociation of sodium sulfate is what? So question number 6. How to do? Sodium sulfate Na2SO4. It dissociates Na2Na plus SO4 minus 2. Okay. So the Vanto factor for sodium sulfate is equal to ICRT. Okay. Why I is taken? Number of ions. So this is, so you IC for C concentration 0.004 is taken. So 0.004 and RT for benzene, for glucose. For glucose, Vanto factor CRT. There is no I. Why there is no I? Because glucose is not dissociated. So there is no I. So CRT, what is C? 0.01 RT. As both are isotonic, then you can equal these two. So I 0.004 RT is equal to 0.01 RT. So both side RT cancel and you will get I is equal to 0.01 divided 004. Okay. So that is, you will get 2.5. Okay. So next, what to do? As sodium sulfate dissociates, as sodium sulfate dissociate to Na plus SO4 minus 2, then what will happen? Let us take it is 1 mole initially. After some time 1 minus alpha, and it is changed to 2 alpha, and it is alpha. Okay. So I is equal to 1 minus alpha plus 2 alpha plus alpha. So total I, how much? Total is alpha cancel and you will get 1 plus 2 alpha. Okay. So 1 plus 2 alpha is your I. But how? What is the I value you are calculating here? The I value is 2.5. So 2.5 is equal to 1 plus 2 alpha. Therefore 2 alpha is equal to 1.5. Therefore alpha is equal to 0.75. Then percentage of dissociation is equal to 75%. So which one is correct? C is the correct answer. Next question. Question number 7. Vanto factor X, Y, Z for association, dissociation and no change of solute in the solution respectively are in the order. So X is for association, Y is for dissociation, Z is no change. So you see the Vanto factor, that is when it is associated, the value is less than 1. Question number 7. That is Vanto factor is less than 1 for association. For dissociation, it is greater than 1. For no change, it is equal to 1. So your association, X is for association, so this is X, and dissociation, that is Y, and for Z, so the order is C, X less than Z less than Y. Okay. Next question. See question number 8. For a weak monobasic acid, if pK value is 4, then at the concentration of 0.01 molar of the acid solution, the Vanto factor is what? You say pK value. Question number 8. pKa value is 4. Then what is Ka value? Ka value is 10 to the minus 4. Okay. So and concentration is given 0.01 molar. So Ka value is given and your concentration is given. So what to do? We know from the what? Ostwald dilution law, Ka is equal to C alpha square. Okay, then what is alpha? Alpha is equal to K by C root over. What is K value given? 10 to the minus 4. What is C? 0.01 root over, that is 10 to the minus 4 by 10 to the power minus 2 root over. So it is 10 to the power minus 2 root over is equal to 10 to the power minus 1. So that is alpha is equal to 0.1 you are getting. Okay. So as HA, it is the weak acid dissociate, HA dissociate as H plus and A minus. So what to do? Initially it is 1 mole and it is 0. So after some time it is changes to 1 minus alpha and it is alpha. So the I value, total I value is equal to 1 minus alpha plus alpha plus alpha. Okay, so you will get to 1 plus alpha. So what is alpha? Alpha is 0.1. So I is equal to 1 plus 0.1, that is 1.1. So 1.1, C is the correct answer. Okay, next, the pH of 1 molar solution of weak monobasic acid is 2. Then the Vanto factor is what? Similar type question. 9 and 8 are both similar type question. So here pH is given 2. So H plus concentration, that is 10 to the power minus 2. Okay. So as it is weak acid HA and it dissociate as what? H plus and A minus. Okay. So C alpha, C minus C alpha and C alpha, C alpha. Okay, it is dissociated as. So total I value you will take C minus C alpha plus C alpha plus C alpha. So total I value is C plus C alpha. Okay, so by taking common C you will get 1 plus alpha. And what is I? This is I. Okay, so what is I? you are getting this one. Okay, so H plus concentration, that is the H plus concentration. This is H plus concentration. Okay, so okay students, so see the concentration is given here what? 1 molar. So you will put 1 and 1 plus what? Your alpha is 10 to the power minus 2. So is equal to 1 plus 0.01. So answer you will get 1.01. Okay, 1.01. So which one is the correct? 1.01. A is the correct answer. Next, at a certain hill station, water boils at 96 degree centigrade. Question number 10. 96 degree centigrade. The amount of sodium chloride that added should be added to 1 liter of water so that it boils at 100 degree centigrade will be what? So Kb for water 0.52 given. So you take question number 10. So delta Tb is equal to Kb I molality. Okay. So delta Tb is what? 100 minus 96, that is 4. Kb is 0.52 and your ionization as sodium chloride is ionized, 2 ions you will get. So I is 2. Molality W2 by M2 1000 into 1 by W1. So you are taking what? 0.52 to W2 you have to calculate. Molecular mass of sodium chloride 58.5, 1000 and it is also 1000. Okay, so both 1000 cancel. By solving W2 you will get 225 gram. So B is the correct answer. Next, 1 molar solution of complex of cobalt chloride with ammonia in water showed an elevation in boiling point equal to 2.02 degree centigrade. Okay, assume that the complex is completely ionized in the solution. The complex is what? The complex. So out of these are the choices given. So you have to find out which one is the complex. So what to do? Question number 11. What to do? You see delta TB is equal to I KB and molality. Okay, molality. So I is what you have to find out, and KB is given what? 0.52, 0.52. Molality 1 molar solution, so it is 1. Okay, delta TB is given how much? It is 2.08. This one 2.08. So 2.08. From this you find I. So I is equal to, by calculating I you will get 4. That means 4 ions you have to get. So this complex, out of this complex, which one is giving 4 ion? This one is giving 4 ion. So this total is giving plus 1, and this chloride answer 3. So 1 plus 3, it is 4. And this is 1 and this is 2. This is 3. So this is 1 and this is 1. This is 2. Okay, so out of the choice A is the correct answer. Okay students, have a good day.